So we've deleted as much of our chocolate data as we feel comfortable doing. Now let's see if we can fill in some of the missing values with appropriate replacements. So let's have a look at our attributes. Right, so we've got company, name, reference, things like this. Bean type has been removed, but we've still got things like the bean origin and the ratings, and there's a few of these missing from our data set. Can we estimate these rather than completely removing them from the data set? Obviously, the less data you use, the less useful things like machine learning are going to be. So let's look at an attribute and see what we can do. So if we look at bar price, right, that's the price of each chocolate bar, we can see that there's a few missing values, somewhere around 3%. Right, that's something we want to deal with, but we've got enough data, 97%, maybe we can start to guess what the prices of these chocolate bars might be. Right? Now, this is a good instance of a time when you wouldn't want to just populate with zeros, right? No chocolate bar is free, I wish. And so what we need to do is produce a reliable value to represent an unknown price, rather than just setting them all to be zero. So what we could do here is something like this. We could set every missing bar price to be the average of all the chocolate bar prices. And that way, at least we're not warping our distribution up or down. We're keeping it exactly the same. We're going to say, for the chocolate data set, for any row where bar price is NA, and for all columns, we're going to set the bar price to be the mean of all the bar prices, right? And we're going to obviously remove any NAs from that calculation, otherwise it's not going to work. Right? And that's already worked. So now, if we recalculate our missing values, you'll see that bar price now has 0 missing values. So we've fixed that problem. Great. So that was quite an easy one, right? Bar price seems to me to be quite an intuitive time when you would just calculate an average and put it in, right? Now, actually, maybe not, because, bar price might depend on where in the world we're selling it, or, what company is producing the chocolate bar. So could we do the same thing for rating? If we take the sum of all the NA values in rating, it's 8. Right, so there are 8 chocolate bars for which there is no rating. So what we can do is we could do something called a stratified replacement. We could say, well, let's group our chocolate bars by country or by company, calculate those averages, and then we can specifically fill in companies' missing ratings based on what that company actually shows in the market, rather than just an average over everything. So what we're going to do is we're going to calculate an aggregate function of the ratings by company, and we're going to calculate a median. Median is a little bit more robust to outliers. So maybe you make up the very, very expensive or very, very cheap line. The median will get what the middle value is, right? So this is going to be per company, and we can set the columns to be a little bit more helpful using col names. And so now our per company, if we look at it, is each company and the median rating of chocolate bar from, I think, 1 to 5, which I think this data set is going. So now we know that data per company, we can actually fill those in. Now you could automate this process, but we don't have much missing data, so let's just show an example of doing it by hand. So this is the line of code we're going to do, and I'll talk through it. So we're going to say for the chocolate data set, for any value where the chocolate rating is NA, so missing, right, and the company is Vicuna, we want to set the rating to be equal to the Vicuna entry in our new per company average or median, right? And that's going to fill in that value there. So we do this for all the missing companies, and what we're going to find is that we've replaced all our missing values with appropriate medians for those ratings per company.